my dear students. Let's start the session. Hi, my dear students. Continuation to the last class, we are discussing Gauss law. Till now, we discussed up to spherical shell. Okay, so this is spherical shell completed and non-conducting sphere, solid sphere completed. So only electrostatic potential in case of non-conducting sphere is pending. From where we started? Electric field due to uniformly charged infinite wire. So we discussed the entire electric field and cube, solid cylinder, then spherical shell also completed. Electric field and electrostatic potential also completed for spherical shell. Then we discussed for non-conducting sphere, it's a solid sphere, volume distribution of the charge, electric field is completed. And now we need to talk about electrostatic potential. Here, electric potential due to uniformly charged non-conducting sphere. Non-conducting sphere. Yeah. So first, we already know this equation. We already know this part. We can extend it. We already know this portion. Here, E bar equivalents to what? E bar equivalents to what? Minus dV by dr. dV is nothing but E bar dotted with dr bar. E bar dotted with dr bar. V reference and up to V. Okay, na? So we need to discuss how to calculate outside of the sphere. Outside of the sphere we already discussed. This is at outside of the sphere, E bar equal to how much? Cube by 4 pi epsilon naught r square. Okay, na? So here we need to do integration from infinity to r. Same thing you will be getting. Okay, outside of the sphere, it's a solid sphere, volume distribution, entire part non-conducting sphere. Okay, so it is uniformly charged, volume distribution of the charge, we are taking, this is the radius of the sphere. Now we are taking a point at a distance r, now we need to bring the unit charge, positive charge, from infinite distance to this point. From infinite distance to this point. From here to here, infinity. Okay, so from here you need to apply the boundary conditions from infinity to r. We already know that E of r greater than r. What is E of r greater than r? Tell me. Here we will be getting 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught q by r square. We already derived this part in the last class. So here what is dV? Here what is dV? Tell me. dV is a scalar. E bar dotted with dr bar. E bar dotted with dr bar. Now just observe dV equals to, here EDR is nothing but 1 by, this is nothing but KQ by R square. KQ by R square into dr. Now we need to apply the boundary conditions. So we need to bring that unit positive charge from infinite distance to r. Infinite distance to r means r equal to infinity. At that time what is the potential? V of infinite. So up to r, that means V of R is nothing but R greater than R. That we will get electrostatic potential at a distance R. Here R is greater than R. So we can take this limits. We already done this. V of R greater than R. V of R greater than R minus V of infinity. V of infinity. V of infinity, of course, 0. That is equivalence to how much? That is equivalence to how much? Here KQ taken common. KQ taken common. Integration R power minus 2 plus 1 by minus 2 plus 1. Minus 2 plus 1. Here infinity to R we need to apply boundary conditions. Then KQ into here KQ. Here take minus out. Then 1 by R will get. 1 by R will get. This is V of R greater than R. E R. This is what? R power minus 2 plus 1. Then infinite distance to this R. Then how much will be getting? Tell me. V of R greater than R. V of R greater than R. KQ by R square into dr. Then 1 by R will be getting. 1 by R will be getting infinity to R. Infinity to R. Then what is this? Minus KQ by minus KQ 1 by R minus 1 by infinity. 1 by infinity. Then 1 by infinity equal to how much? 0. 1 by infinity equal to how much? 0. V of this. Now just have a look on this. Just have a look on this. Here to here, infinity to R, V of R minus V of infinity. So 1 minus is pending. Sorry. Here already we are having minus, right? So this part minus, this is already minus into minus plus C will be getting. Here already one minus is there. Na? So now tell me V of R greater than R. V of R greater than R. Finally, V of R greater than R, how much you are getting? R greater than R, how much you are getting? KQ by R. KQ by R, that is nothing but, just observe KQ by R, that is nothing but E of, this is V of R greater than R. V of R greater than R. 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Q by R. Q by R. If you want to write in terms of volume charge density, volume charge density lo రాయాలంటే ఏం చేస్తారు? Here rho is the volume charge density, Q by 4 by 3 pi times R cube. Pi times R cube. Q equal to 5 pi times R cube అని రాస్తే ఏమొస్తుంది నీకు? ఓకే, సో ఎక్కడ రాద్దాం ఇది? ఫస్ట్ ఇక్కడ వరకు రాసుకోండి. ఇది అర్థమైంది కదా? ఇక్కడ వరకు అర్థమైంది కదా? సో ఫస్ట్ ఈ ఈక్వేషన్ తీసుకోవాలి. ఓకే, we already know this. And then V of R greater than R లాస్ట్ టైం డెరైవ్ చేసాము. ఓకే, దాన్ని ఇక్కడ సబ్స్టిట్యూట్ చేయండి, ఇంటిగ్రేట్ చేయండి. ఇన్ఫైనైట్ డిస్టెన్స్ నుంచి R వరకు తీసుకొని రావాలి. ఇన్ఫినిటీ టు R బౌండరీ కండిషన్స్. R ఈక్వల్ టు ఇన్ఫినిటీ అయితే V ఆఫ్ ఇన్ఫినిటీ అవుతుంది. R దగ్గర R ఈజ్ నథింగ్ బట్ హియర్ R ఈజ్ గ్రేటర్ దెన్ R. R అనేది గ్రేటర్ దెన్ R అవుతుంది. సో అప్పుడు నీకేమొస్తుంది? V ఆఫ్ R గ్రేటర్ దెన్ R కావాలి. అప్పుడు ఈ నుంచి మొత్తము E ఆఫ్ R గ్రేటర్ దెన్ R నీట్గా ఇంటిగ్రేషన్ అప్లై చేస్తే వచ్చేస్తుంది. క్లియరా? ఓకే, సో నువ్వు ఇప్పుడు దీన్ని V ఆఫ్ R గ్రేటర్ దెన్ Rని ఇన్ టర్మ్స్ ఆఫ్ ఇన్ టర్మ్స్ ఆఫ్ రోలో రాయాలని నీకు కానీ అనిపిస్తే వి ఆఫ్ ఆర్ గ్రేటర్ దెన్ ఆర్ని, ఓకేనా. సో ఇప్పుడే కదా రాసింది ఇది, 1/4πε0 Q/R, Q/R. ఈ క్యూ ప్లేస్లో ఏం రాయొచ్చు చెప్పు, ఈ క్యూ ప్లేస్లో ఏం రాయొచ్చు చెప్పు, క్యూ ఈజ్ నథింగ్ బట్ రో టైమ్స్ 4/3 పై టైమ్స్ ఆర్ క్యూబ్, ఓకేనా. రో ఈక్వల్ టు Q/4/3 పై ఆర్ క్యూబ్. సో ఇప్పుడు నీకు ఏమొస్తుంది చెప్పు, 1/4πε0, 4πε0 in place of Q we need to write rho times 4π/3 r cube by r you will be getting. Then what you can write, tell me. Here 4π cancel కొట్టండి, ఈ 4π పోద్ది, ఈ 4π పోద్ది. సో ఫైనల్గా ఏం మిగలద్ది చెప్పు, రో మిగులుతుంది, ఆర్ క్యూబ్ మిగులుతుంది బై 3 times of ε0 r అన్నమాట. దట్ ఈజ్ వి ఆర్ గ్రేటర్ దెన్ ఆర్, అర్థమైందా. ఇప్పుడు నువ్వు వి ఆఫ్ ఆర్ గ్రేటర్ దెన్ ఆర్ని, వి ఆఫ్ ఆర్ గ్రేటర్ దెన్ ఆర్, of course inversely proportional to r, right? Inversely proportional to r. From here to here v of r is constant. It's a hyperbola, rectangular hyperbola, okay na. vr equal to constant లెక్క వస్తుంది, okay. vr greater than r equal to constant. This is a rectangular hyperbola. సో దీంట్లోనే మనము v of r equal to r రాయాలనుకున్నాం అనుకో, అప్పుడు ఏమొస్తుంది చెప్పు, r ప్లేస్లో క్యాపిటల్ R పెట్టేయాలి. అప్పుడు నీకు 1/4πε0 Q/R you will get. This is on the surface of non-conducting sphere. సో ఈ ప్లేస్లో కూడా r రాస్తే ఏమొస్తుంది చెప్పు, v of r equal to r, ఇక్కడ కూడా r equal to r పెట్టు, అప్పుడు రో r²/3ε0 వస్తుంది. రో టైమ్స్ ఆఫ్ r²/3 times of ε0, okay. This is the expression. This is on the sphere, here. This is what, v r greater than r completed, v r equal to r completed. Now we need to talk about v r less than r. ఇప్పుడు మనము v of r less than r రాయాలనుకో, చూడు ఇప్పుడు here to here, this is the thing. Just observe, it would be radius r, uniformly charged, okay. Here to here, uniformly charged non-conducting sphere, volume charge distribution. ఇప్పుడు మనం ఒక పాయింట్ని సాలిడ్ స్పియర్ లోపల తీసుకోవాలి, ఇక్కడ ఏడైనా తీసుకో, ఒక పాయింట్ ఏడు ఉందనుకో, తర్వాత నువ్వేం చేయాలి, ఇక్కడ నుంచి ఇదంతా ఇట్లా గాసియన్ సర్ఫేస్ తీసుకున్నావు, ఇదంతా అయిపోయింది, ఓకేనా. గాస్లో ఆల్రెడీ అప్లై చేసావు. తర్వాత మనము ఎలక్ట్రిక్ ఫీల్డ్, ఇంటెన్సిటీ ఆఫ్ ఎలక్ట్రిక్ ఫీల్డ్ నుంచి E of r less than r. How much you'll be getting, tell me. What is v of r less than r? 1/4πε0 QR² you will get. Here up to here check it once, whether all derivations are correct or not. Here outside the solid sphere, r greater than r, okay, r greater than r, Q/4πε0 r². తర్వాత మనం ఇన్ఫినిటీ నుంచి ఆర్ వరకు తీసుకున్నాం, ఇన్ఫినిటీ నుంచి ఆర్ వరకు తీసుకున్నాం. సో Q/4πε0 1/r. దీన్ని సబ్స్టిట్యూట్ చేస్తే నీకేమొచ్చింది, ρr3/3ε0 ρr3/3ε0 వచ్చిందా ఇది? ఓకే, సో ρr3/3ε0 r వచ్చింది. Vr = r గాని సబ్స్టిట్యూట్ చేస్తే Q/4πε0 capital R ρr²/3ε0. This also completed. We already explained this part. Up to here understood na? Rho = Q/4π/3 pi r cube, 4/3 pi r cube. From here Q we can substitute here. Finally you got this. Inside also 1 by this part na, electric field inside QR/r cube 1/4πε0. We already derived that part in the last class. What is the derivation? R less than R. Q of R less than R. What is the derivation here? QR/r cube. QR/r cube. That's it. What is the expression for solid sphere? Here Q times 1/4πε0 Q times R/r cube. Q times of R/r cube. Linear distribution. So same manner we need to apply this. dV = minus E bar dot dr bar. Now just observe, dV = in what manner we are applying boundary conditions important. E is nothing but 1/4πε0 Q times of R/r cube. Q times of R/r cube dr. Now I want to move from R to R. It is very simple to answer. Here I want to move from R to R. Okay, I want to move from here. This would be R1 = R. Okay, so here to here, R2 you can take. R2 = R. So here the thing is, I want to move from here to here. I want to move from here to here. Understood? So initial R. I want to move from R to R. Last time infinite distance to R. Here we already know V of R, right? That is why I am doing like this. Okay, now that is up to you. Potential difference and boundary conditions. It is simple way to answer this question. Okay, so here to here, just observe. We are moving from where to where? R is equal to R. R = R. R = R is nothing but, here you will be getting V of R. Okay, na? R = R means V of R = R. That also you can write. This is nothing but V of R = R. So here R up to R. This is V of R less than R. R less than R. Now once you apply this integration, apply the boundary condition. V of R less than R minus R less than R minus V of R equal to R. Up to here it is clear. అర్థమైందా ఇప్పుడు వరకు? ఇక్కడ మనం ఏం చేస్తున్నాం అంటే, లాస్ట్ టైం ఇన్ఫైనైట్ డిస్టెన్స్ నుంచి, అప్పుడు నువ్వు ఇన్ఫైనైట్ డిస్టెన్స్ ఏడకి ఏ నుంచి లోపలికి చాలా క్లమ్జీ అయిపోతుంది. అలా కాకుండా ఆర్ నుంచి ఆర్కి వెళ్ళిపోయావు అనుకో, వి ఆఫ్ ఆర్ = ఆర్ నీకు తెలుసు. ఓకేనా? అది సబ్స్టిట్యూట్ చేస్తే నీకు వి ఆఫ్ ఆర్ లెస్ దెన్ ఆర్ వచ్చేస్తుంది. ఓకేనా? సో ఇక్కడ చూడు ఏమొచ్చింది నీకు. ఇక్కడ మైనస్ దీన్ని కేగా రాసేసే పోద్ది, KQ/R3. KQ/R3. by r cube. Here integration of r is nothing but r square by 2 you will be getting. R square by 2. R square by 2. ఇక్కడ నీకేమొచ్చింది చెప్పు r to r apply చేయాలి. So then what you people are getting? In this case just observe v of r less than r నీకు తెలీదు, r equal to r తెలుసు, kq by క్యాపిటల్ r అనే విషయం నీకు తెలుసు. ఇప్పుడే కదా ప్రూవ్ చేసింది దాన్ని. kq by r, kq by క్యాపిటల్ r అనే విషయం తెలుసు నీకు. తర్వాత మైనస్ kq by r cube, minus kq by r cube. Here what you people are getting? ఆ 2ని ఇక్కడ పడి here r square minus r square వస్తుంది. r square minus r square, r square minus r square. Then how much you will be getting? v of r less than r, v of r less than r, that is equal to minus kq r square by 2 times of r cube. Here plus kq r square by 2 times of r cube plus kq by r, kq by capital R, kq by capital R. ఈ మైనస్ ఇలానే వచ్చింది, తర్వాత మనం లోపలికి పంపించాం. సో ఇది తీసుకొని పోయి అవతలకు పంపించేస్తే, దీన్ని తీసుకొని పోయి అవతలకు పంపిస్తే you will be getting like this. This part you can take it to here. Okay, this part you can take it to here, multiply inside v of r less than r, v of r less than r, that is equal to how much you are getting? 3 by 2 kq by r na. Here to here we can cancel it up. ఈ r square పోద్ది. kq by r అంటే 3 by 2 kq by r వస్తుంది. ఓకే, సో మైనస్ ఇక్కడ మనము kq by r గాని తీసేసాం అనుకో. ఇప్పుడు మనం ఇక్కడ kq by r గాని తీసేస్తే ఏమొస్తుంది చెప్పు? kq by r గాని లేపేస్తే ఏమొస్తుంది? ఇక్కడ మనకి మైనస్, ఇక్కడ ఏమొస్తుంది? kq by r తీసేస్తే 3 by 2 వస్తుంది. ఇక్కడ 1 plus 1 by 2 3 by 2 minus here kq by r తీసేస్తే r square by 2 times of r square by 2 times of r square. Now here entire 2r square taken LCM, kq by 2 times of r cube, 2 times of r cube. In that case 3 times of r square, 3 times of r square minus r square will be coming. Put r equal to r, now we will get. Okay na? So what is the expression for v of r less than r? v of r less than r, that is equal to kq by 2 times of r cube, 3 times of r square minus r square will be coming. This is the expression. Write down up to here. Just have a cross check on this. Are you getting same? See this, here to here r greater than r, outside also completed. What is this? We already done this part. So now r less than r, just now we derived it, just have a look on this part. So r to r we are interested, capital R to small r, What is E of r less than r? This is what V of r less than r. This part is nothing but E of r less than r less than r. Okay na? So we applied r to r, then v of r less than r minus v of r, everything we did. Finally how much you are getting? Finally how much you are getting? Here kq by what we got, tell me, just compare it. Kq by 2r cube, kq by 2r cube. Here v of r less than r, v of r less than r, how much you are getting? kq by 2 times of kq by 2 times of r cube, 3 times of r square minus small r square. Are getting same or not? Check it once. Here k you can replace with 1 by 4 pi epsilon naught. Here v of r less than r, that is equal to how much? 1 by 4 pi epsilon naught means 1 by 8 pi epsilon naught q by q into 3 times of r square minus r square by r cube we will be getting. R cube we will be getting. Understood? Same thing now. If you want to substitute in place of q, you can substitute v of r less than r, v of r less than r, that is equal to 1 by 8 pi epsilon naught. In place of q, we can substitute rho into 4 pi by 3, 4 by 3 pi, 4 by 3, this is pi, what is this? Here it is how much? 4 pi by 3, pi times, this is r cube you are getting, 3 times of r square minus r square, here by r cube you are getting. Then finally how much you are getting here? Then this part cancelled out, 4 pi by 3, this 2 times cancelled out, 2 times cancelled out. Then what you will get, tell me? This r cube gone, r cube gone. Then 3 2 is 6 na. Here rho times denominator, 3 2 is 6 epsilon naught. Numerator how much will be getting? 3 times of r square minus r square you will be getting. That is v of r less than r, v of r less than r, v of r less than r. Clear? Same thing. Okay. So here rho times, here rho by 6 epsilon naught, 3 times of r square minus r square. This is more than enough. If you want, you can take it out. So q by 4 pi epsilon naught r cube, we already done this. Q by 4 pi epsilon naught r cube, 3r square minus r square. Okay, if you put r equal to 0, at r equal to 0 you are getting rho r square 2 epsilon naught. That means you need to draw the graph. At r equal to 0 you are getting, this is at r equal to 0. At r equal to 0, how much you are getting, tell me? Rho r square 2 epsilon naught. At r equal to 0, rho r square, v of r equal to 0, rho r square by rho times of r square by 3 times of epsilon naught, rho times of r square by 3 times of epsilon naught. Here we already done this part. V of r less than r, v of r less than r, this part is how much in terms of here v equal to r square na, it look like what, it look like what, v equal to this is entire part, some constant you can take, this is some constant minus some constant c1 r square. Okay, it look like it is taken on y axis, right? It is taken on y axis, it is taken on x axis, it is taken on x axis. It look like very simple, y equal to okay, here it is x square na, entire part if you take like this, it will look like a parabola, right? Y equal to some constant kind of stuff 4a x square. Okay, generally it is what, if you take that constant to the left hand side, x square equal to 4ay kind of stuff, x square equal to 4ay, pole will be shifted. Okay, 4ay y minus h kind of stuff, y minus k, okay, pole will be shifted. So what kind of parabola it is, it is y, it is x, what is the principal axis, y axis is the principal axis, it look like this, correct or not, it look like this, same thing, right? Up to here it's a parabola, okay. So we need to write like this, here y x square equal to 4a y minus k kind of stuff. So that is why y axis is the principal axis. Actually it will come like this, understood? It's a parabola, up to here it is a parabola. This part is how much, v r less than r, okay na, inversely related with r, means into r equal to constant. Okay, so that is looking like xy equal to constant, that is rectangular hyperbola. Okay, this would be rectangular hyperbola, understood? You know that this is the rectangular hyperbola, along this you will get, understood? So do you know this or not? Here to here rectangular hyperbola. So same graph you will be getting like this. Okay, inversely related means rectangular hyperbola, it's a parabola, so that is why you will get like this, understood? Up to here it is clear, understood or not? Entire discussion is clear. From the beginning, just observe. Okay, Q enclosed like this we have taken. Okay, inside E of r less than r ds, Q enclosed inside 0. So after that we discussed this part. Okay, Q by 4 pi epsilon naught r square, inside outside all cases covered. Okay, E of r, this part E of r less than r. Now here if you are interested you can draw the graph. I will explain this graph again. This is V, R is taken here, Now V of R less than R, V of R less than R, that is equal to how much? Rho by 6 times of epsilon naught 3 times of R square minus R square will be getting denominator R cube. Denominator how much you are getting? R cube already gone, right? Here rho by rho by 6 epsilon naught 3R square minus R square. Next one is how much? On the surface rho R cube by 3 epsilon naught R. Here rho R cube by 3 epsilon naught R. Here V of R greater than R is nothing but rho R cube by 3 times of epsilon naught R. Okay, R equal to R how much? 2 times of epsilon naught. 2, 3 na? 3 times of epsilon naught. Put R equal to 0. First R equal to 0. Put R equal to 0 here. Here it is how much? R equal to capital R. Next region R is greater than R. Here R less than R. Okay. So in this case at V of R equal to 0. Put V of R equal to 0. Put R equal to 0. Then rho times of R square by 3 2 jana 2 times of epsilon naught. That means graph should start from here. Graph should start from here. I explained right. Up to here it is what? From here to here. It's a parabola. It's a parabola. It's a parabola. You should get like this. It's a polo. It's a parabola kind of stuff. Then after that we can go up to here enough. Okay, so it's a parabola. This graph like this you will get. It's a parabola. Okay, so up to here it is a parabola. After this it's a V of rectangular hyperbola. After this would be rectangular hyperbola. That is the logic. Rectangular hyperbola. Understood na? So it's a parabola. Up to here parabola. This would be rectangular hyperbola. Understood? V of R less than R. If you substitute anywhere V of R equal to R. How much you will be getting? V of R equal to R. How much you will be getting? R equal to capital R in the sense 2 times of R square 3 times of epsilon naught. Rho times R square by 2 3 ja 3 times of epsilon naught. It is going up to infinity. V of infinity equal to 0. It is approaching 0. Okay. So here what is this? In this region R greater than R region. This is R less than R region. Understood? Now you can substitute here also. R equal to capital R rho R square by 3 epsilon naught you will get. This is R equal to capital R. This is R equal to 0. Okay. So it is going like this. It is a rectangular hyperbola. This is looking like VR equal to constant. It look like x square equal to 4a some constant into y minus k. Y is the principal axis. It look like a parabola. What look like? It is parabola. Parabola. This is what? Rectangular hyperbola. It is rectangular hyperbola. Hyperbola. Okay. So entire Gauss law is completed. Electrostatic potential. Okay, electrostatic potential also some of the topics that part na electrostatic potential will come in the next chapter. That is also completed.